This section has two main parts. The first part is function operations and the second part is function composition. So let's start with the operations. So given two functions, f and g, we can perform operation on them. We can add, we can subtract, multiply, and divide. So f plus g of x is f of x plus g of x. F minus g of x is fx minus g of x. Fg of x is f of x times g of x. F over g of x is f of x over g of x, with the condition being g of x cannot be 0 because we cannot divide by 0. Let's look at a few examples. F plus g of 1. So f plus g of 1 is the same thing as f of 1 plus g of 1. And f of x is given x squared plus 1 and g of x is given as 3x plus 5. So f of 1 is 1 squared plus 1, which is 1 plus 1, which is 2. G of 1 is 3 times 1 plus 5. So that's 3 plus 5, which is 8. So f plus g of 1 then is f of 1 plus g of 1, so that's 2 plus 8, so that's 10. So f minus g of minus 3 is f of minus 3 minus g of minus 3. So let's find f of minus 3. F of minus 3 is minus 3 squared plus 1, which is 9 plus 1, which is 10. G of minus 3 is 3 times minus 3 plus 5. So that's minus 9 plus 5. So that's minus 4. So f minus g of minus 3. So that's 10 minus minus 4, which is 10 plus 4, which is 14. So fg of 5, that's f of 5 times g of 5. So let's find f of 5. F of 5 is 5 squared plus 1, which is 25 plus 1, so that's 26. G of 5, 3 times 5 plus 5, so that's 15 plus 5, that's 20. So fg of 5 then is 26 times 20, which is 520. So f over g of 0, so that's f of 0 over g of 0. So f of 0 is 0 squared plus 1, so that's 1. G of 0 is 3 times 0 plus 5, so that's 5. So f over g of 0 is 1 over 5. Go ahead and work on these and see if you get the same results. So the bottom part is similar, but now we look at the value from the graph. So this line is a graph of f of x, and this is the graph of g of x. So f plus g of 4 is f of 4 plus g of 4. And now let's look at the graph to get f of 4. F of 4 is 9, and g of 4 is 2. So this is 11. So f minus g of 0 is f of 0 minus g of 0. So f of 0 is 1, and g of 0 is 0. So this is 1. So f minus g of minus 2 is f of minus 2 minus g of minus 2. So f of minus 2 is minus 3. and g of minus 2. So g is only defined from 0 to infinity. It's not defined anything less. So g of 2 is not undefined, so in this case this is undefined. F times g of 1 is f of 1 times g of 1. So f of 1 is 3 and g of 1 is 1. So that's 3. Fg of 0, that's f of 0 times g of 0. So f of 0 is 1 and g of 0 is 0. So this is 0. F over g of 1, that's f of 1 over g of 1. F of 1 is 3 and g of 1 is 1. So this is 3. G over f of 1 is g of 1 over f of 1. And we already know g of 1 is 1 and f of 1 is 3. So this is 1/3. G over f of 0, that's g of 0 over f of 0. So g of 0 is 0 and f of 0 is 1. So this is 0. So f over g of 0, then that's f of 0 over g of 0. So f of 0 is 1 and g of 0 is 0. So this is undefined because it's 1 divided by 0. In this example, f of x and g of x is not evaluated at any particular x, but we can still perform the operation. So for example, for a, f plus g of x, that's f of x plus g of x. So that's 8x minus 9 plus square root of 2x minus 1. B, f minus g of x. So that's f of x minus g of x. So that 8x minus 9 minus square root of 2x minus 1. C, f g of x, f of x times g of x. So that's 8x minus 9 times square root of 2x minus 1. And d, f over g of x, that's f of x, g of x, f of x divided by g of x. So that's 8x minus 9 divided by square root of 2x minus 1. But then you condition that 2x minus 1 cannot be 0. So let's look at the domain in this function as well. So first let's look at the original function. F of x equals to 8x minus 9. So this one, there's no restriction on x. So the domain of this function is all real numbers. So for g of x, square root of 2x minus 1, the restriction on square root is that 2x minus 1 cannot be negative. So 2x minus 1 has to be greater than or equal to 0. So let's find what the x were. So add 1 on both sides, get 2x greater than 1 divided by 2. So x is greater than 1/2. So this is the domain for g of x. X has to be greater than 1/2. Domain for f is all real numbers. So f plus g of x, we have this new function. The domain has to be the intersection of all f and g and also any new restriction. For this one, the domain for this one then is just the same as the of g of x, because this part there's no restriction on x, so the domain for this one is just x greater than 1/2 or 1/2 to infinity. Same thing with f minus g of x. It's intersection of these, and there's no new restriction. So the domain here is also x greater than or equal to 1/2. Same thing here, it's just multiplying, so there's no restriction, exert restriction, so the domain is also x greater than 1/2. In this case, there's a new restriction because we can't have 0 denominator, so 2x minus 1 cannot be 0, so that means x cannot be 1/2. So the domain is x strictly greater than 1/2, or 1/2 to infinity, with parentheses. Go ahead and work on these problems and then check the answers. So f of x, 2x plus 4, g of x, 2x minus 5, so there's no restriction on f or g. So the domain for f and g are all real numbers. So f plus g of x, that's f of x plus g of x, so that's 3x plus 4 plus 2x minus 5. In this case, we can simplify them. So 3x plus 2x, that's 5x, and then 4 minus 5 is minus 1. And the domain is all real numbers. F minus g of x, so f of x minus g of x, so 3x plus 4 minus 2x minus 5, which is 3x plus 4 minus 2x plus 5. So 3x minus 2x is x, and 4 plus 5 is 9. And the domain is also all real numbers. F times g of x, 3x plus 4 times 2x minus 5. So 3x times 2x, 6x squared. 3x times minus 5, minus 15x. 4 times 2x, 8x. And 4 times minus 5, minus 20. So we can simplify the middle two terms. So 6x squared, negative 15x plus 8x. That's minus 7x and minus 20. And there's also no restriction here, so the domain is all real numbers. F over g of x over g of x, so that's 3x plus 4 over 2x minus 5. So this time there's a new restriction, so we cannot have the denominator to be 0, so 2x minus 5 cannot be 0. So that means x cannot be 5 over 2. So the domain is all real numbers except 5 over 2. And we can write it negative infinity to infinity minus the element 5, 2, or r, that's represent real number, the set of real numbers, except 5 over 2. So here, let's start with the domains of f of x square root of 4x minus 1. That means 4x minus 1 has to be greater than or equal to 0. So that means x has to be greater than or equal to 1/4. So domain is 1/4 to infinity. And for g of x, the only restriction is that x cannot be 0. So all real numbers except 0. So f plus g of x, square root of 4x minus 1 plus 1 over x, so we cannot simplify this anymore, so that's the answer. And the domain is just the intersection of each part. So this part requires that x cannot be 0, and this part requires that x has to be 1/4 and higher. So 1/4 and higher, and it cannot be 0. So this has to be this part, because this one also covers that it cannot be 0 already. So the domain is 1/4 to infinity. So same thing with f minus g and f times g. The domain are both 1/4 to infinity. For f over g, we can do for x minus 1 over 1 over x. That's f over g and 1 over x. That means it becomes x square root of 4x minus 1. In this case, it's the same. The domain is still 1/4 to infinity because this part. Composition of functions is basically a function of a function. So function is like a machine. You input a variable x into this function g. The result is the function g of x. And this function g of x is used as the input of this other function f. So the result is the function f of g of x. So here's an example. So if we have a $40 pair of blue jeans that is on sale for 25% off. So $40. This function is 25% off of the $40. So that's $10 off. So the discounted price of this jeans is $30. And on this special occasion, they offer additional 10% off. So this 10% off is not applied on the original $40. The 10% off is applied on this $30. So it's only $3 off more. So the discounted price total is $27. That's the final price. Composition of functions can be written as f of g of x. That reads f of g of x. So it's a function f of another function g of x. So let's look at an example. So we have f of x is 2x minus 1 and g of x is 4 over x minus 1. F of g of 2, that's f of g of 2. So we work from the inside out. So let's find g of 2. So g of 2, we plug in 2 into this function g, so that's 4 over 2 minus 1. So that's 4 over 1, which is 4. So f of g of 2, that's the same thing as f of 4. And f of 4, we can plug in the 4 into this x in the function f. So that's 2 times 4 minus 1. So that's 8 minus 1, which is 7. So same function f and g. We're looking for f of g of minus 3. So that's f of g of minus 3. So let's look from the inside out, right? G of minus 3. Plug in the minus 3 there. So that's 4 over minus 3 minus 1. So that's 4 over minus 4. So g of minus 3 is negative 1. So f of g of minus 3 is f of minus 1. So f of minus 1, 2 times minus 1 minus 1. So that's minus 2 minus 1, so that's minus 3. Go ahead and try these and check the answers. So f of g of 5, f of g of 5, and then g of 5 found to be 16. So f of 16 is square root of 16, which is 4. So this one is a little different, but it works the same way. So it's g of f of 4. So that's g of f of 4. So we need to find f of 4 first. So f of 4 is square root of 4, which is 2. So this is g of 2. So the result is 3 times 2 plus 1. So that's 7. This last one, f of g is negative 2, f of g of negative 2, g of negative 2, we find it to be negative 5. And when we plug in f of negative 5, it gives us square root of negative 5. This is a special case because we can't have square root of negative 5 of a negative number. So this function, the composite function, is undefined at x equal to negative 2. Or you can say it's outside of domain, and we'll look at the domain in a little bit. In this example, we're given a table of values of f and g, and we can find the composite by just reading from the tables. So f of g of 2, that's f of g of 2. So we work from the inside still, right? So g of 2 is 4. So this is f of 4. And f of 4 is 8. So here we're looking for g of f of 7. So that's g of f of 7. And f of 7 is 2. So that's g of 2. And g of 2 is 4. We can also find f of f itself. Right, so f of 8, that's f of 8. So f of 8 is 5. So this is f of 5. And f of 5 is 9. So here we're looking at the domains of the composite functions. So before we look at the composite ones, let's look at the domain of the original functions. So square root of x, that means the domain is from 0 to infinity. And for g of x, there's no restriction, so domain of g is all real numbers. So let's find the composite f of g of x. So f of g of x, that's f of g of x. And g of x is 4x plus 2. So that's f of 4x plus 2. So we plug in the whole 4x plus 2 in place of the x in the function f. So that's square root of 4x plus 2. So now this new composite function, there's also a restriction because it's the square root of a number. So that means 4x plus 2 has to be greater than or equal to 0. So let's find out the x. So 4x greater than negative 2. Divide by 4. So x is greater than or equal to negative 1/2. So this is the domain of the composite function. But also we have to look at the composite of the inside function. In this case, g of x, the domain of g of x is all real numbers, so the domain of the composite function is just going to be the domain of 4x, square root of 4x plus 2. So the domain for f of g is negative 1/2 to infinity. So now let's look at g of f of x. So that's g of f of x. And f of x is square root of x. So g of square root of x, so we plug in 4 square root of x plus 2. So the domain for this is x has to be greater than or equal to 0 because of the square root. So we have to look at the domain of the inside function of f of x. So the domain of function of f of x is 0 to infinity. So it's actually the same. So the domain of g of f of x is also 0 to infinity. So here we have a function f of x is 6 over x minus 3, and g of x is 1 over x. So the domain of f is all real numbers except for 3, because 3 would make the denominator 0. So r minus 3. And same thing here for g of x, we cannot have x to be 0. So the domain of g is all real numbers except 0. So now let's find the composite function and its domain. So f of g of x is f of g of x. So that's f of 1 over x. So for f of 1 over x, we plug in 1 over x wherever x is. So that's 6 over 1 over x minus 3. Then we can simplify it and we get 6x over 1 minus 3x. So now there's a new restriction. So 1 minus 3x cannot be 0. So solve for x, and then we get x to be 1 over 3. So we cannot have x to be 1 over 3 because that would make the denominator 0. So altogether, the domain of the composite function would be this restriction combined with the restriction of the inside function, which is g of x. And the restriction for g of x is that cannot be 0. So the dimension of the composite function is all real numbers except 0 and 1/3. So any numbers except these two. Here the function g of f of x, that's g of f of x. And f of x is 6 over x minus 3, so that's g of 6 over x minus 3. So we plug in this into the function g, so that's 1 over 6 over x minus 3. So that's the reverse of that would be x minus 3 over 6. So this new composite has no restriction because the denominator is a number, so it's not 0, and x can be any number. So just for the domain of the composite function, we just need to look at the domain of the inside function, which is f. And the domain of f is all real numbers except 3. So the domain of the composite function g of f is all real numbers except 3.